Let's discuss the discovery of electron, that is generally known as the cathode rays experiment. In this experiment, a gas discharge tube was used. Inside the gas discharge tube, a very low pressure of a gas was maintained. Two metallic electrodes, cathode with negative charge and anode with positive charge, were suspended and connected to the high voltage. The discharge tube was also connected with a vacuum to maintain the pressure inside it. When a very low pressure and high voltage of about 2000 volts was applied, some rays were seen traveling from cathode to anode. When these rays were studied by J. Thomson, he called them the negatively charged particles. As these rays travel from negatively charged cathode to the positively charged anode, therefore they should be negatively charged because opposite charges attract each other. And J. Thomson concluded that these rays were the negatively charged particles. These rays travel in straight line. These rays were able to produce a glow in rare earth metals and minerals. If rare earth metals or minerals placed in their paths, they produce a glow on the wall of discharge tube. Upon exposure to the cathode rays, alumina glows red and tin stone glows yellow. If we place a solid object in the path of cathode rays, they will cast a shadow of that object on the glass of discharge tube. If we place a wheel in the path of cathode rays, that wheel starts rotating, which means these cathode rays are material particles having certain mass and velocity, or in turn they possess momentum. These rays, if bombarded on a node of large atomic mass, they are able to produce the X-rays. These rays ionize the gas, they bring about the chemical changes because they have reducing effect, and they pass through the aluminium and gold foil. According to J. Thomson, these materials are negatively charged particles. So scientists calculated their charge to mass ratios and they found that their E over M values always remain constant. Later on, Stoney called these negatively charged particles the electrons. Why the E over M value of cathode rays remains the same? Because the electrons are present in every atom.